Okay, one last thing I wanted to show is I was going to use an isolation transformer on my scope to remove the earth ground, because this earth ground goes to these connections here, and some amps do not like ground on their negative terminal, and definitely not on their positive terminal. So Class AB amps are fine. A lot of them, like those 2 amps, the negative on the speakers are actually ground. But like when you testing car stereo amps, you know, you're taking a risk. So this isolates the earth ground on the scope from the work. And this is a little cheaper. This is what's called differential probe, high voltage differential probe. And this is just a little cheaper one, and I say cheap, this thing was like $200 and something, I believe. And Handtech's okay brand. This thing had pretty good reviews, and it does work well. Because I was looking at audio off of that, and it works fine. But these things are usually used for high voltage. And right now I got it on like 50. So it's like 50 volts per division. To the scope, so you have to turn the scope down by 50 times to see that signal, and then it goes up to 500. And I don't see too many people do this, you know, for checking amps, but this is actually a good option, and that's what this thing is for. You know, it isolates the scope from whatever you're working on. And I got this little connection from Amazon, man. It's pretty slick, and it's gonna go to the RCA on the back here that's connected across the amp terminal, which is also connected to this. And I've tested on that radio. I can see audio just fine. Of course, I gotta turn the volts division pretty sensitive, but even that little 1-2 volt signal, I see it pretty good on there. It's nice and clean coming through here. And this thing has its own power supply. It's a little wall wart back there. But I just wanted to show that I went with this. So that will eliminate any problems hooking an amp to the scope. Because like I said, you gotta be careful. Because see the scope ground, it goes to the probe. This ground right here is also that power earth ground. And some amps, man, you hook that up, you'll blow that amp. And also, you can also look at the power socket voltage with this one, no problem. You can with a regular probe, but you got to make sure that your ground is on the neutral prong and that the center prong's on the hot. Because if you reverse it around, there ain't nothing nice. You're gonna have fireworks. So I just wanted to show that. It's gonna live back there behind all that stuff, and we'll be able to see the signal on the amp just fine. I won't be able to see that clip. So I just finished all this stuff up. I've been working, and then I came home. I went to Georgia to see my grandbaby for his birthday. So it's kind of put me back like 3 weeks on this thing. And of course, in my other video I showed y'all, I temporarily got this Crompton. The other meter I sent to Weschler. They're gonna program in the peak hold on it. Because it was an option, you had to order it with that option, but I talked to them on the phone, and they said, yeah, we could do it. We got to hook up to it with our software and a 232 connection internally and enable that option. And they charged me $100 to do it. So the only thing is, they're like 8 weeks backlog. So he told me yesterday on the email when I checked on it, he said, man, it's like 8 weeks. So I kind of bit the bullet. I had this meter. This meter is 4 to 20 milliamp. Okay. So 4 to 20 is what runs the thing. So I had to get a isolator converter. And those aren't exactly cheap either. I got a cheaper one from China, and it works quite well. It converts 0 to 75 shunt voltage drop to that 4 to 20 signal. And I tested this thing today, and it reads current pretty good. It reads about what the Fluke does. Now, clamp meters, I'm going to tell you guys something about clamp meters. On DC, and I don't mean AC, on DC, the DC clamp meter is fairly accurate. It's not going to be super accurate. There's some things to consider, like extra magnetic fields. You constantly got to zero the damn thing. Whether the wire's going through it, it's best to have it through the center and, you know, directly at 90-degree angle to the clamp to get the best current meter. You know, any moving around stuff can change it significantly. So the most accurate way to read DC current is with a damn shunt like that, because it's calibrated to give a certain voltage drop for a certain amount of current. And that little meter right there, these are real meters, guys. This is stuff that's used in the industry. This is some switchboard meters. I work offshore, you know, oil and gas, and we use a lot of this stuff, especially on generators and power and stuff. And I'm gonna tell you from my experience, for almost 30 years working out there, this stuff is fairly accurate and it's very reliable stuff. Okay, and Crompton is a really good brand, and they do make good stuff, and so does Weschler. Okay, so I'm pretty confident that the current we reading on this is pretty accurate. Also, though, this thing kind of samples slow, so it takes a moment to register that current. It's not as fast as that Fluke clamp meter. And also, I ordered a Unity 2000 amp AC/DC clamp meter, and it's a cheap clamp meter, but Unity is actually a decent brand, and it's coming. And it's just, you know, just to have a backup, because my Fluke only goes to 600 amps, and I'm sure if we do some big stuff, you know, it's going to max that little clamp meter out. And I'm not paying through the nose for a Fluke that only does 1,000 amps, you know, because I think the biggest one I got does like 1,000. You know, like Big D got the one with the detachable little face where you can read it remotely and all. That's all slick and all, but you know what? This is what I got. So this is what we use. So I hope you guys enjoyed me kind of slapping this thing together. It's definitely been an experience. I still got to get under there and just kind of tie wrap up some of the wires. Goes over there and comes to my deal. And I ordered those little wing nuts, like I said in another video. I never got them, so I tried to order some more, and a week or two went by and they never even shipped them. So I got these nice little anodized aluminum thumb screws. And when I told y'all I got some longer things, what I meant was I got some little extensions. They like little standoffs to screw into the original ones SMD put here. And I put a little Loctite red so they'll stay. But this worked out pretty good, man. These that's a little 4mm 0.7 pitch, and the little threads are 10mm long, like what Steve Mead originally had in there. But that worked out good. And like I said, I went and I put heat shrink on everything that didn't have heat shrink, and it took an incredible amount of time to do all this, you know. And this was not a cheap project by any means. I know it don't look like it But, you know, all this crap's expensive, man. Even though I did a lot of it myself and put together a lot of this stuff myself and didn't buy it all primed and polished like a $7,000 SMD 81 and all that. That would have just really been ridiculous. So we're gonna give this thing a shot. Tomorrow, if I got time. My wife, she got me pretty hemmed up right now, but I may hook an amp to this tomorrow and give it a shot. I got some 2-aught out in the Tahoe, some runs that I'm going to use for battery lead for that. It was hooked to that Hifonics 8K that's still sitting in my Tahoe. It's not turned on or anything. I've been using the 16K B2 Riot, but I've just been too lazy to take it out. So I'm gonna get all that stuff together and I'm gonna play with this thing and see how it does. And I really wish I would have known more about these batteries before I bought them, because they're really only made to charge up to about 14 volts, and pushing them to 14.4 is really stressing them and probably shorten the life of them. And when I was doing that load test, when I was pulling that 460 amps, don't really have much of a voltage drop between this meter and this meter anymore with them 4 runs, but it does pull that battery bank down. It went from like 13.8 to like 13.1 volts with just 460 amps. So, you know, these batteries, I don't know how hard the previous owner was on them. I bought them used. These things were supposed to be all great and stuff. I watched them on Jag 35, and just one of these banks did like 800 amps for like, I don't know, 5 or 13 minutes. He was running inverter with it, and it only dropped down to, I think it dropped down to like 13 or 12.95 or something after all that time. But man, only 400 and something amps, this battery bank sags that much. I'm kind of concerned. So what that means is I'm gonna have to put that damn 500 amp power supply in parallel with it to kind of keep it from sagging too much. But I'm at the point of no return on this crap. I'm not buying nothing else, because all this shit was too damn expensive, and kind of, hate to say it, I kind of regret doing this now, because had I known how damn expensive this would have been just for even this, and I went, trust me, I try to go as cheap as I can, and some stuff I had to have, like the relays and stuff in this ESD, and this just for, you know, logical reasons to make this safer, because this crap is in my house and I don't want to blow nothing up. As you notice, I didn't put no fuses on there. And if you don't know, fuse is just a little thin piece of metal, and it gets a voltage drop, y'all. Okay, I didn't want any voltage drops. This is my fuse right here. We got a problem, power off. I'm the fuse. So that's why I don't have fuses up there, if you want to know. All right, till next video. I'll get something going. I'm probably going to test everything first, make sure it works, and then do a video on it so y'all can see. And I don't know, I may start with that Orion HCCA D5000, or maybe the Taramps Base 8K, depending on how this is going to act. So I got to figure out how this big vagina is going to act, and, you know, do the right things to make it happy. So, all right, there's your final update right there. Peace out.